This is Algebra 1, Lesson 16-1. Today's date is Friday, April 19th, 2019. Make sure your name and date are on your papers. All right, so we are in our brand new unit. It is a long and slightly difficult lesson. I guess this lesson isn't so hard. I guess it's a long and slightly difficult unit, so just be prepared for that. Let's start with a bunch of vocabulary. So we are studying this shape for this entire unit. This shape, write it down, is called a parabola. I'm going to write it up here. Parabola. So when I talk about parabola, you know that I'm talking about this U shape. It does go off forever and ever to the top left. It does go top right forever and ever. So there should technically be arrows on here. So if you could add that also. All right, so this parabola, I say that this parabola is opening up because these two arrows are going up. So this opens up. Opens. Maybe we should write it off to the side because I need to do something in the center. So I'll say it opens up because the arrows are pointing up. You can say that arrow is pointing up and this arrow right here is pointing up. You can have something, you don't need to write this down, you can have a parabola that looks like this, which means it's opening down because the arrows are pointing down. Or you can maybe think about this, if this was a glass, it's upside down and spilling out water. All right, so there is something called the axis of symmetry, and I want you to try to figure out where that is. If I were to fold this shape in half, where would you fold it in half? Where would you crease the paper? Obviously, you're not going to crease it right there. That doesn't make sense. How are you going to crease it in half? Go ahead and draw that line right now. And you don't need a ruler or anything. So hopefully you are seeing that you should be drawing this line right here that goes through x equals -3. And that actually is the line x equals -3, so we'll write that down. This is x equals -3. Notice it's not y equals, it's an x equals -3. Generally speaking, at least for this unit, we will always have an axis of symmetry that's x equals to something. In this case, the x-intercept of that line, which is -3. All right, so let's do another vocab word. This point right here. This point is on the parabola. It's also on the axis of symmetry. It's the lowest possible point. It's like the tip of the iceberg or of this quadratic or this parabola. So I call this point right here the vertex, V-E-R-T-E-X, vertex. And if I have multiple of them, if I have two of them, they're called vertices, vertices. That's the plural form. So vertices and vertex. So this has one vertex. And this vertex, I'm going to write the x and y coordinate of the vertex. I go -3 in the x direction, and then I go -2 in the y direction. So I have a -3, -2. That is the coordinate of the vertex for this parabola. All right. Some words that you already know, I'm sure. This point right here is called the y-intercept. Y-intercept. Because that is where it intersects the y-axis. So this up and down line is the y-axis, so it intersects this line at y equals 7. And I also have x-intercepts. I have multiple of them. I have an x-intercept here and here. It's kind of hard to tell what this is. Let's just go ahead and assume that this is -4.5. So I'm going to say -4.5, 0. Got some lag there, -4.5, 0, and this would be -1.5, 2, -1.5, 2. Those two things are called the x-intercepts. We'll label that as well, x-intercept. And there are two of them in this case. You can have one intercept, you can have no intercepts, you can have one or two intercepts, you can have a bunch of different numbers. You cannot have 3 intercepts, because there's no way for this function to come back down to intersect the x-axis again. All right, so I want to talk about how to find the vertex. Again, the vertex is that bottommost point, or it might be the topmost point if it was upside down like this. How do I find the x-coordinate of the vertex, knowing that my x-intercepts are at x equals 1 and x equals 7? So I want you to pause at least for 30 seconds, try to figure this out on your own, looking at this diagram. I have two x-intercepts. How do I figure out this x-coordinate? Oh, thank you, go away. How do I figure out that x-coordinate, knowing that these two x-coordinates are -4.5 and -1.5? Hopefully you were thinking of a point that was halfway in between these two, because this I forgot to even label this. Can we label this as well? This is called the axis of symmetry right here. This is called the axis of symmetry. This axis of symmetry goes through the vertex. I can figure out that this -3 is halfway between -4.5 and -1.5. So how do I say it's halfway in between 1 and 7? I add them and divide by 2. It's kind of like taking the average. So you're going to do add both and then divide by 2. So for example, I'm going to add 1 plus 7, 1 plus 7. I'm going to divide by 2. 1 plus 7 is 8. And 8 divided by 2 is 4. So the x-coordinate is 4 for the vertex. You just have to add both of them and divide by 2. All right, so this is probably the main thing that I want to talk about today. It's the zero product property. Although it is really nice to have the vocab ready, the zero product property is the main focus today. So if I have a times b, and I know that a times b is 0, what do you guys know about a and b? And again, this is one of those times that you really should pause the video 30 seconds. What do you know about a and b if a times b is 0? Okay, so you've unpaused the video now. If a times b is 0, you know either a is 0 or b is 0. For example, if a was 0 and b was 3, then it would be 0 times 3. 0 times 3 is 0. Maybe a was 7 and b was 0. 7 times 0 is 0. One of these things has to be 0. Maybe both, but we don't know. So generally speaking, we're going to set both equal to 0 just in case both happen to 0. So, and I guess that deserves its own star as well. We'll add our own star. Set both to 0 just in case both happen to be 0. That means a equals 0 and b is equal to 0. From now on, if you have a times b equals 0, set them both to 0 just in case they are both 0. All right, now let's extend that knowledge. Now I'm going to change it from a. It's no longer an a, it's an x plus 1. Instead of a b, it is now a 2x minus 4. I'm still multiplying two things together. If this blue thing times this yellow thing is 0, what do we know about that blue thing and yellow thing? And again, you need to pause the video, attempt this on your own, either out loud, on paper, do something to where you're predicting what this is going to be. If you're not predicting, you're not doing the notes. Okay, so you've unpaused the video. It's the same answer. We set both to 0. That means this x plus 1 is 0 or this 2x minus 4 is 0. We say that algebraically. So I'm going to say x plus 1 equals 0. X plus 1 equals 0. This thing, you can put parentheses if you want, but I'm going to drop them since we don't need them anymore. This thing equals 0, and we also have to assume that this 2x minus 4 equals 0, just in case they both happen to be 0. So from now on, whenever you see two things are multiplied together and they're set equal to 0, set them both equal to 0. So x plus 1 equals 0, and then I'm going to solve two different equations. Let's do the equation on the left. I need to solve, so I'm going to do what to both sides? Yes, you're screaming at the computer, subtract 1, Mr. Sindel, subtract 1 on both sides, and the 1's cancel out, and you're left with x just by itself is equal to -1. On the right-hand side, it requires a little bit more work. I'm going to add 4 to both sides, add 4 to both sides, and that will cancel out the 4, and I'm left with 2x is equal to 4. From there, I need to do something else. I now need to divide both sides by 2, divide both sides by 2, and the 2 cancels out, and I'm left with 4 divided by 2, so therefore x is equal to 2. Notice that we have two answers here. I have an answer right here, and I have an answer right here, x equals -1 or x equals 2. I'm going to go ahead and give this knowledge. I'm going to talk about it later, but the reason that we have two answers is because we have two x-intercepts. All right, so let's do example 1, solving for x. I have one thing times another thing equal to 0. Set them both equal to 0. All right, pause the video. You do this now, solve both of them. All right, you've unpaused the video. Let's go ahead and do this. 3x plus 5 is equal to 0, or, I guess, and x minus 7 equal to 0. We have to do both of these equations. Let's do the one on the left. I'm going to do a subtract 5 on both sides, and that's going to get rid of the 5, and I have a negative 5 on the right. I still have a 3x left over on the left. Now I need to divide both sides by 3, divide by 3, divide by 3, and now x is equal to just this fraction, negative 5/3. That's one answer. Let's box that one answer. We're going to box a second answer as well. All right, I need to solve this second equation. I have to add 7 to both sides. Add 7 to both sides. These 7's cancel out. I'm left with x. On the right-hand side, 0 plus 7 is 7. There is my other answer. I have two answers here. All right. Example 2. Again, you should pause the video. Try example 2 on your own. All right, you've unpaused the video now after trying this for maybe 5 minutes and gave up, or maybe you solved it in 1 minute, whatever it took. You're now watching the answer because you have tried. So this negative 4x minus 1 is set equal to 0, or this 3x plus 2 is equal to 0. I have to set them both equal to 0, and then I solve. I'm going to add 1 to both sides, add 1 to both sides, undoing the 1, and I'm now left with a negative 4x equals to 0 plus 1 is 1. All right, now I'm going to divide both sides by negative 4 to cancel out the coefficient out front. These negatives and 4's are gone. This is also going to be divided by negative 4. And now I'm left with x. X is by itself. X is equal to this fraction, negative 1/4. It doesn't matter how you write this. That equal sign was a little bit sloppy. You can write this as negative 1/4. You can write this as negative 1/4. You can write this as 1 over negative 4. All of these are the same thing. It doesn't matter the order, or not the order. It doesn't matter where that negative sign is, as long as you have at least one negative sign. All right, let's also solve this right-hand side. So I'm going to subtract 2 on both sides. The 2's will cancel out. I'll be left with a negative 2 on the right-hand side. 2's are gone, so just a 3x on the left-hand side. Now I need to get rid of this coefficient to isolate x, so I'm going to divide both sides by 3, divide both sides by 3. 3's cancel out. I'm left with x is equal to negative 2/3. That is my second answer, and box it. I have two answers. As a note on Khan Academy, you will be entering the smallest value first. So if I had to decide which of these two values is the smallest, this one is the smallest. So this guy right here is the smallest. The reason that I guess it's the most negative. I guess if you're talking about distance from 0, this one is farther away. But which one is most negative? It is this one, because if I look at a number line between, let's say that this is 0, this is 1, this is negative 1. Negative 1/4 is about right here, negative 1/4, and negative 2/3 is about right here, negative 2/3. So negative 2/3 is farther to the left on the number line, whereas negative 1/4 is farther to the right, even though they're both negative values. All right, that concludes today's lesson. Go ahead and write your summary down here. You should definitely have something about this zero product property, maybe some vocab words that you didn't know before. After you finish the summary, the homework is on Khan Academy. There are 2 assignments, one talking about vocabulary and one talking about this zero product property.